Alright, in this section here we're going to be graphing some quadratic functions. So in the past we have been focusing mainly on just linear functions, but in this section it's quadratic. So first thing we need to do is, what is a quadratic function? Well, a quadratic function looks like this. Now I'm going to write it like it's an equation. You know, we could write f of x here if we wanted to, but I'm just going to write it with y is equal to ax squared plus bx plus c. Okay, a, b, and c are all elements of R. Alright, so these can all be real numbers, except we'd have to say that a cannot be equal to 0 if we want it to be a quadratic function. Now, of course, we're focusing here on graphing quadratic functions, and we're going to look at their graph, and we're going to identify what's called the vertex on the graph. So let me just kind of sketch out, and of course we're going to actually use a graphing utility because my pictures aren't pretty most of the time. This one here, we'll say y is equal to x squared. Alright, so I'm going to try to graph this out. What does this graph look like? And it looks something like this. Okay, and the graph of a quadratic function has a name, and the name of this is what's called a parabola. Alright, so the name of this curve is known as a parabola. Now you notice there's some symmetry going on here. It has the vertical axis of this parabola happens to be the y-axis, and so it's symmetric about the y-axis. In other words, this side of the curve here is a mirror image of what's going on in quadrant 2. So quadrant 1 is a mirror image of quadrant 2, and quadrant 2 is a mirror image of quadrant 1. Now, this part down here, this point right here at the origin, this is known as the vertex. The vertex. So if we're given this, we want to be able to tell where's the vertex located. Well, in this particular case, and I'm just going to label this with a V, okay, the vertex is 0, 0. Alright, the vertex is 0, 0. Now let's take a look at if we start moving this thing around, what does this thing start looking like? When we start moving this guy around in the plane, move the vertex over here, for example, and now we have a parabola over here. How does that actually change this? And so that's what we want to kind of look at. We're going to look at that, and then we're going to also look at what happens. How can I flip this curve? Get a reflection about the x-axis. Alright, so we're going to kind of look at some things like that, and I think what I'll do here is just redraw it, or at least attempt to. Okay, so this guy here we're going to say is y is equal to x squared. If I wanted to flip this guy, so we get a mirror image about the x-axis, we just throw a negative out in front. Throw a negative out in the front, and that'll cause this to flip. You see that? That's pretty interesting. What if I wanted to get the curve to move up vertically? Let's say up to 2 here on the y-axis. Well, we would just add 2 to it. You see that? What if I added 2 to this one? Well, that would cause this curve, and I'm going to draw this in purple, that would cause this curve to go up 2 units in that direction, so it would be shift. So we're adding a constant on the end of this and causing the graph to move vertically up or vertically down. Okay, if this were, for example, a negative number, so let's look at this again. So, for example, if I had y is equal to x squared, and I wanted to move this down 2 units, we would say x squared minus 2. So that would move it down. We'll say negative 2 is here. So that would shift the graph down 2 units, as you can see here, shifting it down 2 units. Alright. What we haven't talked about is what happens if I wanted to shift this graph. We've been talking about reflecting it by throwing a negative out in front and shifting it up or down. But what if I wanted to, and you know what, let's just make this a different color this time. Add some color to all this. Let's say I wanted to shift the graph over. Okay, so let's say that's 0 and that's 2. If I want to shift this graph over 2 units, now keep notice that the vertex right here, I'm going to write the vertex. The vertex is 2, 0. Okay, and the vertex here is 0, 0. If I want to shift the graph over 2 units, what I'm going to do here is we have y is equal to x squared. I'm going to plug in x minus 2. So I'm going to substitute an x minus 2 in for this x right here. Now look what happens. If I take a 2 and I plug it in, 2 minus 2 is 0, and 0 squared is 0, and therefore y is equal to 0. Alright, that just tells us that this point is located right here. So this shifts it over 2 units to the right. Okay. If I were to shift it 2 units back in this direction to negative 2, then in this number right here, we're shifting it negative 2. So this would become y is equal to, we're going to plug a negative 2 in, and a negative, a minus, and a minus is a positive, so you get x plus 2 squared. And so this graph right here, or this function here, okay, will correspond with this graph. We plug negative 2 in, negative 2 plus 2 is 0, y is 0, so we know that that's the point right there. That would be the vertex. Alright, so shifting it to the right, we would put minus to whatever number we're going to. Shifting it to the left, we're plugging in this negative number into here, okay, and a negative is positive, so it seems like minus here you'd be going that direction, and plus you'd be going in that direction, but you got to keep in mind that that plus, because we're putting in a negative number right here, and a minus and a negative is plus. Okay, all right, so now we know how to shift it left and right and up and down and reflect it, right, by throwing a negative out in front. So I think we should clear the whiteboard, and now so let's say that I have x minus 2 squared plus 2. Where in the world is this going to be located? Well, we want to go to the right 2 units, and we're going to go up 2 units, and so we end up with a parabola that looks like that. Okay, where this is the vertex right here. The vertex is at 2, 2. See that? Vertex is at 2, 2. Alright, so this is the vertex 2, 2. What if I wanted to reflect this graph? So it looks something like this, reflected about the point 2, 2. What would we need to do there? Let's just start with this. Let's look at this piece here. Y is equal to x minus 2 squared. So we'd come over 2 units and it would look like, right, this is what the graph would look like. We'd have shifted the graph 2 units to the right. Okay, now we want to reflect this graph, so we'd throw a negative out in front of it. So it'd be x minus 2. Right. That would cause the graph to reflect, and I'll do that in a different color. So it would look like that. Now we want to take this graph and move it up 2 units. So that means that we have to add 2 to it. So then we have y is equal to negative x minus 2 plus 2. Right, so we end up moving the graph up 2 units, which gives us this graph here. Okay, so all we did was, these two are virtually the same in a sense, except the only difference is there's a negative. We threw a negative out here in front of the x. You see that? We threw a negative out in front, okay, in front of this piece right here. So the idea is we want to be able to get around, reflect and take that vertex. All we're doing is taking the vertex and moving it around. So if you haven't realized yet that these two numbers are the key numbers to finding our vertex, okay, these two numbers right here are the key to finding the vertex. And in general, and of course we'll be talking more about the vertex in the next section, but this is the formula that you might see, where of course a is not equal to 0, and that the vertex is the point h and k. So it's whatever these numbers are right here. Okay, so keep in mind this must be a minus. Now if this were a plus right here, this would end up being a minus h. Alright, a minus h. So you need to keep that in mind. Okay, keeping that in mind. Well, this was graphing a parabola, also known as a quadratic function, and I think we're going to leave it at that. Now, we didn't really talk about how to actually graph these things. We talked about what their forms look like and so forth, but I'm thinking that you should probably know at least how to graph them. I guess we'll stick with this purple looking color. Y is equal to x squared. If I had to figure out how to graph this, what I would simply do is, this is my x and this is my y over here. Take 0, plug it in, you get 0 out, right? Take negative 1, should have done that first. Square that, you get 1. So you're just plotting points, right? So 0, 0, negative 1, 1. Alright, plugging in 1 into this, you get 1 out. Of course, this is symmetric. And you would just continue down through here plotting points. And then what you do is just connect the dots. And that would just be a simple way of knowing what the graph looks like. But the key here is we want to find this vertex and then this line right here. And then we can pretty much tell, right, what our graph's going to look like.